Hello, everybody. We are going to get started here in just a couple minutes. We'll start right around 1 o'clock. Right now, everyone, we got some people trying to get logged into the webinar page here. And so we're going to give them just a minute. But again, thank you for joining us, and we'll get started in just a couple minutes. Just a note here, if you are having any difficulties, everyone is muted, but you can use the chat box if you have any questions or are having any problems. Please use the chat box. Welcome, everybody. It'll just be another minute or two. We're getting everyone logged into the web page here to the webinar. So please be patient, and we'll get started in just a minute or two. If you're having any issues, please use the chat feature there because everyone is muted. Okay. Okay, we're going to go ahead and get started. Mary, I don't have, are you going to take the logo down? Thank you. So I can pull up my notes. All right, well, good afternoon, everyone, and thank you for joining us. My name is Chris Vonamy. I am the Deputy Director for the DuPage County Stormwater Management Department. And we are here today for a Raise the Bar on Stormwater Design webinar, where we will try to shift our mindset to embrace stormwater as a valuable resource rather than a troublesome waste product. We will learn how strategic creativity can empower engineers and planners to design and execute cost-effective, resilient stormwater management solutions. This is a free webinar, and 1 PDH or professional development hour will be available. We have several of these workshops throughout the year. The Illinois Environmental Protection Agency requires this training under the National Pollutant Discharge Elimination System program. So we are encouraging governmental staff, including stormwater, public works, and transportation staff, and other contractors that could be out there to attend and view these webinars. Again, 1 PDH will be available for your participation. And if you have other staff that could not attend this afternoon, this webinar is being recorded and the presentations will be made available for viewing at their convenience. We will email the link with this information shortly following the program. Okay, just a couple thank yous before we begin. I'd like to thank Mary Mitros. Mary is our Stormwater Communications Supervisor, and she helped organize this webinar. I'd also like to thank the Conservation Foundation. They are our partners for all of these workshops, specifically Jan Rail. She is the DuPage County Program Director for the Foundation, and she helped line up our speakers for this afternoon. And once again, I'd like to thank all of you, our audience, for joining us. Now for just a quick public service announcement. Please pay close attention because I'm sure many of you have not heard this before, but we hope that everyone remains safe and healthy during these difficult times and continues to practice good hygiene by washing your hands frequently, social distancing, and wearing a mask in public. If you do feel sick or ill, please isolate yourself or quarantine to prevent the further spread of the coronavirus. Okay, thank you for bearing with me through that. Just a couple more things. Please remember that snacks and refreshments will be provided in your own refrigerators. And if you do have to use the restroom, please be aware that everyone is muted, but let's make sure we turn those cameras off. I only mention this because we did have a situation last month where one of our employees, and I'm not going to mention any names here, but Rob forgot that his camera was on, and bingo. You get the picture. Hopefully you didn't get the picture. But anyway, that's not important right now. What's important right now is that we have 4 great speakers with us this afternoon. We have Andy Sauer, Adam Blunstein, Aaron Przyblinski, sorry about that, Aaron, and Madison Gibler, all from Burns and McDonnell. And they will tell us about stormwater designs that provide a more holistic evaluation of urban hydrology so that we can manage stormwater more sustainably. But before I turn things over to them, I do want to remind everybody, everyone's is muted. And so if you do have questions or comments during the presentations, please type them right into the chat box and we will relay those on to the presenters following the end of the presentation. And we'll get to as many of those comments and questions as time will allow. Okay, I do want to introduce each of our speakers. I'm not exactly sure what order they're going to go in, but I do want to say a few things about each presenter. We'll start with Andy Sauer. Andy is the Green Infrastructure and Stormwater Manager for Burns and McDonnell. He has over 23 years of experience in water resources, stormwater management, and green infrastructure. Andy holds a bachelor's degree in agricultural engineering and a master's in agricultural and biological systems engineering from the University of Nebraska. Next is Madison Gibler. Madison is a civil engineer and she helps communities, organizations, and businesses develop sustainable environments through green stormwater infrastructure, stormwater conveyance, and watershed planning. Madison has her master's degree in environmental engineering and a bachelor's degree in civil engineering from Missouri University of Science and Technology, which is formerly Missouri-Rolla. Aaron Przyblinski, Aaron is an environmental engineer and has been with Burns and McDonnell for 5 years. She graduated from Purdue University with a bachelor's in environmental and ecological engineering. Aaron has experience in water, wastewater, and stormwater projects for municipal industrial clients and has developed an interest in green infrastructure solutions. And finally, Adam Blunstein. Adam is a civil engineer and has been with Burns and McDonnell for 4 years. He has experience working on a range of projects, including stormwater, wastewater, and water resource projects for municipal, industrial, and transportation clients. Adam graduated from the University of Illinois at Urbana-Champaign with a bachelor's degree in civil engineering. So welcome, thank you for being here with us. And right now, Mary, if you don't mind turning things over to them, we'll get started with the presentation.
All right. Well, thank you for the introduction, Chris. Definitely appreciate that. And thank you everyone for coming today. We really appreciate the great turnout. We are really excited to talk through this topic, raising the bar on stormwater design. And our stormwater team here, as Chris mentioned, myself, Adam Bloomsey, I'm in the Chicago office, along with Aaron Prisbalinski, who's also in our Chicago office. And then Andy Sauer and Maddie Gibler are both out of our Kansas City office, and we work pretty closely together with them. I will say we have a quick poll we wanted to, oops, excuse me, trying to control. We have a quick poll we just wanted to put out to the group just to get a little bit of an idea of kind of the background and where everyone's from. So feel free to take a few moments just to answer that poll, and I'll continue to talk through and share where we're going to go with this presentation. So today's presentation includes a little bit of discussion on why green infrastructure is important, and moving along to how do we evaluate some of our stormwater needs and find better ways to evaluate that from what we've been doing in the past. Moving forward a little bit to talking about stormwater design in DuPage County. We don't want to hit too much because we know most of you guys probably know DuPage County better than we do. Stormwater, then move forward towards stormwater design and talk about some other locations that we've worked on across the country and some of our experience working in different areas and kind of how that compares a little bit to DuPage County and what other places are doing. And then talk a little bit about some creative solutions that we've implemented on different projects and our component-based approach to implement these specific parts of the project or specific stormwater components on these different projects and how they might fit in, and then kind of wrap up and summarize our theme, raising the bar. And we're going to kind of bring that up multiple times. You'll hear us talk about it and kind of reconnect different components of stormwater management and really how we can do better. So I'm going to close the poll now. It looks like we've got a good attendance here and a good responding, and looks like we've got a lot of engineers and government agency officials. Appreciate everyone coming. I know everyone appreciates a free PDH too, but definitely appreciate you guys coming to listen to today. So without any further ado, I'm going to pass along to Andy. He's going to talk a little bit further, kind of start off the presentation.
Thanks, Adam. As Adam was saying, appreciate the opportunity to talk today. I do many of these talks, different conferences, and of course with our wonderful pandemic, we now do a lot of Zoom meetings and Teams meetings. So appreciate everybody joining today. I want to start off today by just giving some examples to kind of set the stage about why I should care more about doing better stormwater designs. I've been in this industry over 23 years and worked on projects all over the country. And through that process, I've collected a whole series of pictures, which I'm going to share a few of those today, because now as I get older in my career, I'm asking the question, are we really solving the problems with stormwater issues? And so if we go through here with the next slide, I'll just introduce a few of the things that I've seen, especially over the last 10 or 15 years when I've started to think about this a little bit more holistically. Is if you think about it, you know, stormwater, typically we have a higher risk, but oftentimes we do a very simple or maybe a lower technical evaluation. I've reviewed projects for cities that, you know, be upwards of millions of dollars of projects or millions of dollars in construction dollars, and it's based on a rational calculation. I often wonder, you know, are we best investing our funds when we have such a limited technical evaluation? And then if you think about the way we do even stormwater modeling, we have many assumptions we put in the models, but we very rarely verify those assumptions. It could be everything from curve number to percent impervious area or how water is actually collected. We just assume it all gets there. So a lot of assumptions, but we very rarely verify those. We often have limited monitoring data, so we really don't, I would argue, really don't understand a lot of times how our stormwater systems are actually functioning. I've spent a lot of time in the last few years looking at detention basins specifically, and how much value detention basins and the current configuration of trying to meet a typical peak mitigation, where we're trying to shave a peak off, really provide value to the downstream community. And what you find is it's amazing how limited that value really is in real historical rainfall events. So that's got me thinking. It's also got me thinking about some times where we conserve to a fault, meaning as we add new infrastructure and make it larger to meet our ever-changing climates, are we passing that problem downstream, and what are those impacts? Are we really understanding those risks of those downstream impacts? And then as we redevelop or develop, a lot of our solutions are done by at the development engineer level, and I would argue that sometimes those are smaller projects, but we don't understand the overall impact that those smaller developments have on the overall system. And so sometimes I refer to that as like a death by 10,000 cuts. We continue to improve our system upstream with redevelopment development. We don't understand how that impacts downstream, and so we see problems. And then unlike other public infrastructure, I would argue that we don't often maximize the current infrastructure we have and get full value out of it. And are there ways that we can do that better in the future? And I would argue there are. And then finally, we all live in this boat, and even the EPA and the federal government's looking at ways that we can get more dedicated funding, because stormwater, as we all know, fortunately is kind of the last one to the table. Excuse me. And we don't have enough funding to address the issues that we're going to talk about here today. So that's, I know, a big problem. So if we move on, Adam. So why should we care? Well, we all care because we're on this webinar, obviously, but our number one thing we're doing with stormwater improvements is we're trying to mitigate flooding, right? And so I've looked around the country and looked at different things, and we do projects, and you look back in the future, and we still have all these wonderful flooding problems in urban areas. There's always a storm that we can't manage, and we see this often, and I know in every community from DuPage County to Kansas City, all these areas have these issues. So when we think about this, do we really understand when we do improvements, what are the issues downstream, and are we truly mitigating flooding as we look throughout the system? So next slide. I'm going to go through these pictures fairly quickly so we can stay on time. And then this is my biggest one I've looked a lot at in the last few years is when we're doing system improvements upstream, do we think about how, especially if we're discharging to natural streams, what are the impacts of that more efficient hydraulic collection system? This picture on the left was something that happened within about 18 months after this large RCP went in, and how devastating that was to the downstream stream. We see infrastructure like such things as sanitary sewer systems that were in the bank of a stream now are in the center of the stream, and we see larger infrastructure on the right that now is being undermined by a stream widening. So all these things are things that we need to think about. How can we do better designs to not have this adverse impact downstream? We also see this in our road crossings with large culverts being undermined, or wing walls for a recently completed project are all of a sudden falling into the stream. Well, that obviously causes us, from cities or municipalities, significant dollars to repair. And we just mentioned that we don't have enough dollars, so can we think about these designs and make them so that they're more resilient, so that we're not having these issues right after we've constructed them? So those are all things to think about. And then of course we have the aging infrastructure. The aging infrastructure is a huge problem, obviously, but it's also an opportunity when we're looking at these areas, when we're improving these. Can we look at these systems a little bit differently, and can we do projects differently that we're not replacing the aging infrastructure all the time with just larger pipes? Can we manage the stormwater a little bit differently? So can we do better? So we have a couple examples we're going to talk about as we move through this presentation. A lot of times we say, well, we're adding inlets to get more capacity, quote unquote. But what I find a lot of times, we don't look at the actual enclosed system capacity. We just add inlets, and the case on the left, that was done several years ago, and there was no improvement in the street flooding there. It was just, you know, an improvement, and what it ended up being is just impacting the pavement more than helping with anything. And the item on the right was a project that Maddie's going to talk about a little bit more, where this city had some flooding in this public alleyway, and so they went in here and just added this great inlet. And the real issue, the real problem was they had over 4.5 acres of directly connected impervious area, and the downstream system was an old, antiquated system, had no capacity. Adding the great inlet actually did nothing, and so it was just didn't help anything. And so they didn't understand the problem, so they weren't able to solve the problem. And so Maddie will show an example of how we did a little bit different design to help address the problem, rather than just adding an inlet. We looked at what the problem was and then designed a solution to solve the problem. And these are some of my favorite slides. You know, we do stormwater, but then we try to, you know, make sure the stormwater doesn't get in contact with vegetation. I love this. So we have a lot of detention basins that have concrete flumes at the bottom of them, so the most frequent water doesn't get to the vegetation. I call them flow in, flow out detention facilities. So I argue, you know, what's the value we're really getting out of these systems? We're mowing them, but we're not doing anything else with them because there's very little water gets outside of the flume a lot of times. We do curb setback inlets, and then we also spend money on vegetation and trees right behind the curb inlet, but once again, we don't connect any of those. In this picture on the upper right, you know, we're using an alligator bag to irrigate the tree, and we're trying to keep everything alive, and meanwhile, we have a stormwater inlet, and we're not connecting anything to the vegetation from a stormwater standpoint. And then my favorite picture is, you know, the tree, you know, completely surrounded by curbs, and how sustainable is that, right? We're spending money on trees. Many cities, counties have, you know, landscaping tree ordinances, and then we're putting them in a concrete prison and thinking, well, I hope that tree lives. I would hate to be that tree. You get what, 18 inches of space to try to live. So these are all things I think, can we do better? And I would argue, yes, we can. And so how does that look? Well, we've been doing a lot more with various different cities, and is looking at ways where we're looking at stormwater as more of a resource, and how can we design and implement projects from as large as the one you see on the left to as small as the one on the right. But we're using that stormwater to maintain a vegetated system that is capturing, controlling, and I think that's a big one, controlling being key, and then conveying stormwater. So we're not just capturing and conveying, we're using green infrastructure or other places to use that water, control it before we're immediately conveying it downstream. Other things we've been doing is kind of optimizing existing systems or optimizing stormwater function with real-time controls, where once again, we're able to, in an adaptive situation with real-time controls, manage stormwater before and after a rainfall event by using the National Weather Service forecasting, in this case through a company called OptiRTC, where they're able to predict the probability of rain, and then we can lower or open a valve to increase the storage volume in real time, so that we can optimize that facility and get a higher benefit from that stormwater retention. And then, of course, in many urban areas, the pervious pavers are a great application where we have large parking lots, where we can, what I refer to a lot of times as more continuous collection. So instead of collecting stormwater at a curb inlet or grade inlet, we're now using this continuous collection idea with pervious pavements, and then storing it temporarily underground in either aggregate storage or plastic crate storage to get that control again before we're then discharging it downstream. And then, you know, using more open systems, once again, in open swales, vegetated swales, where we can collect, store, and convey. So all these options we're just showing, just start to look at what are the multiple benefits that we can get with stormwater, and the solutions start to look, of course, a lot different. So with that, my final introductory slide here is that we'd like to, you know, really understand and solve the problems, and then provide that multiple benefit. We want to maximize the limited stormwater dollars we have and to increase the benefit. We want to increase the level of evaluation to reduce, and I would say reduce all the risk, not just maybe the upstream risk. I think we all have a goal to optimize our current assets, and smart technologies, continuous modeling, optimizing those systems is a way to do that. And then considering the total cost of management, of stormwater management, and how that impacts downstream assets. So if we're solving a problem upstream and just passing it downstream, there could be significant cost in that solution that we're not necessarily considering. And then finally, I've done a lot of work in the last few years on updating city and county standards, design standards, because if you don't understand the standard you're trying to implement, can you actually even afford to meet the standard you're trying to meet? So with that, that's kind of my broader overall introductory comments, and also some conclusion comments at the end. So I'll turn it over to, I think, Aaron next.
Yeah, awesome. Thanks, Andy. Those are some great examples. And just to kind of reiterate a few of those main takeaways, we wanted to highlight a few things we noticed on a flood control project in Cook County, just to bring some of these questions home regarding how we're managing stormwater locally. So the first being, are we considering what's happening downstream? Or if we travel a bit further downstream, are we seeing conditions similar to this first photo on the left of some pretty serious stream degradation and bank erosion? I mean, you can see the overhang and the root system that's gradually been carved out and exposed, and the bank is inching further and further into the property adjacent to that stream. So when we're evaluating an area that's flooding, is our design really solving the problem, or are we just sending it downstream? Secondly, how can stormwater impact our utilities, such as that utility pole in the middle photo that we found located in the middle of that stream? Guessing it wasn't originally designed and constructed that way, but without proper management, that water is eventually going to get to where it wants to go, potentially impacting nearby utilities and infrastructure. And finally, can we shift our mindset to view stormwater more as a resource rather than a waste? And the first step to capturing that resource is really asking the question, are our stormwater design methods and standards setting us up for a sustainable design? So an example of that is how we typically evaluate our designs. And a commonly used method is looking at these discrete events. So just how a single individual event would impact your design. We ask ourselves, can it withstand the 100-year, 24-hour storm? Yes, great, sign and seal it. But we don't really consider how having several smaller events occurring within a short period of time, which is not an uncommon occurrence in this region, how that could impact how our system performs. On top of that, the rational method is very dependent on certain parameters that can kind of be manipulated to sometimes get the answers you want. And like Andy mentioned earlier, often the modeler needs to make assumptions to fill in those parameters in the first place. And it's always possible that, you know, those assumptions could be inaccurate. So a more robust methodology that we can use is continuous simulation. So that's the next slide. Setting up a series of rainfall events to run through your design to get a more comprehensive perspective of how your system is going to perform, you know, over the weeks, the months, the years. You can even consider using recently reported data from your region if it's available, which would give you even better tailored results. But really getting away from that peak flow analysis can help us better understand the risk of system failure. Even if we continuously evaluate system performance throughout just the duration of a single storm, we might see that, yeah, it's at capacity during the 10-year, but maybe only for 4 minutes. You know, is this something we're willing to accept, and you can make a more sophisticated, kind of multifaceted decision rather than a binary, does it cap out or does it not approach, because risk is really more complex than just yes or no. So maybe we should consider shifting away from that lower technical evaluation that Andy mentioned earlier with that higher risk, and more towards higher technical evaluation with a more complex understanding of those risks. And risk really lives in the future tense, right? And we have dozens and dozens of rainfall distributions that have been developed by different agencies. This is kind of on the next slide. And these have been, developed using years and years of data that's been collected to try and predict the future rainfall events. But I guess the question is basing our designs on these past storms and past data going to set us up for success in the future? For example, did you predict this storm event back in May? And I'll hand it off to Adam to tell us a little bit more about this photo.
Cool, thanks, Erin. So yeah, we talked a little bit about modeling and a little bit about local storms. So this picture shows a local storm from May 2020. So I think a lot of you guys probably remember this storm in the region. This was a mid-May storm. This particular picture is showing the downtown Naperville River Walk, which I think a lot of you are familiar with. Right now, it doesn't look like much of a walk. It looks like more of a river, but it's a nice place to go when the water's low. But kind of the question is, are we thinking about, in this particular instance, we had heavy rains in the region, even tornadoes in some areas. There was an earlier rain in midweek. I think it was around the 14th and the 15th of May, which dropped about an inch and a half of rain in the Naperville area. And then another 2 inches of rain fell over the weekend, I think on that Sunday on the 17th. In some areas of Chicago is up to like 3.5 inches of rain. So kind of those back-to-back storms, are we considering that? Or are we looking more at, like Erin said, these discrete events where we get a larger volume of rain potentially, or even a quick burst of rain, but with the soil saturated potentially from these previous events that could cause, and streams full of water, that could potentially lead to more disastrous effects. So that's kind of how can we change our mindset, thinking about rainfall on kind of on a longer scale as opposed to just each event by itself. So kind of going along with rainfall, I think all of you guys are familiar with Bulletin 70, and Page County now using Bulletin 70, looking at how that's changed over the years. And previous to 2019, when the Bulletin 70 update occurred to the rainfall depths, I've highlighted over here the about 7.5 inches of rain for 100-year 24-hour, which is commonly what we use to design our detention basins and major stormwater facilities. Then you look at what's happening after the update that was made in 2019, and what the majority of communities are now using going forward is look at almost an inch more of rain for the 100-year 24-hour event. So the climate scientists looked at the past historical rainfall data in the region and kind of extrapolated going forward, what are we going to see? So climate change is something that we all need to think about and design for, and the State Water Survey is trying to take that into account, and I know a lot of communities are doing that as well. Kind of, again, going back to the example of back-to-back events, the one downfall of looking at maybe just this 100-year 24-hour event, are we considering potentially how events back to back could affect our designs. And also even the smaller events, could we be potentially over designing for most of the events, or not even controlling the right amount of water, and maybe for these smaller events we're just letting out too much water as opposed to looking at these larger events. So these are kind of things to think about as we're designing, and obviously we have to consider the standards, but as an engineer, you always just need to, in the back of your mind, be thinking, what I'm doing, does it make sense, and not just blindly follow. So kind of moving on, I'm going to touch this real briefly because obviously the group is familiar with DuPage County, so just touch a little bit about on some of the topics. So related to some of the topics we're going to cover further in as we compare it to other communities. So you can kind of see how things may differ in Northeast Illinois region versus other parts of the country. If you look at the DuPage County Stormwater Ordinance, kind of two things we just wanted to highlight, and there's a lot of areas that we could talk about, but as we look at best management practices, requirement is if there's 2,500 square feet net new impervious, you have to design for post-construction BMP using a 1.25 inch rainfall event. You could find that in the ordinance. And that's looking at volume and pollution control, and also taking into account the main component is to encourage infiltration, which is a great thing, and that's one of the ways we talk about raising the bar on stormwater. Again, also site runoff storage is another area we look at. We talked a little bit about the 100-year 24-hour, and talked a little bit about release rates. So again, the ordinance does mention about not increasing for that 2-year event as well compared to pre-development, which is a good thing. So again, it's kind of looking at not just one single event, looking at multiple events, and also how smaller events, which could potentially be affecting our system more frequently than these larger events, how does that affect our infrastructure? As we move on to BMPs. So DuPage County is a pretty developed BMP manual. You guys can reference it through the Stormwater website. And kind of DuPage County breaks down their BMPs into 3 categories. Stormwater treatment, which is really looking at quantity and quality. So infiltration and vegetated swales are a few examples of those types of BMPs. Sediment control, so preventing that sediment to get into the water bodies. So that could be your typical silt fence, sediment traps, those types of things. And then pollution prevention, which is more of a maintenance and operations approach, looking at how you can prevent by doing street sweeping, spill prevention control, and other measures to prevent kind of longer term pollution into our waterways. And really it comes down to, if you look at this table, which is also taken from that BMP manual, is really minimizing our impervious surface. So raising the bar, we can, by implementing more infiltration and green type solutions, we can prevent really a lot of the impact that we would potentially have on our waterways. So now I'm going to pass it to Maddie. She's going to talk a little bit more about what some other communities are doing that we've worked with.
Yeah, so Adam gave some great examples locally there. I'm coming at you with some ideas from what other communities are doing. Also a perk of, I guess, COVID is that we can see what other communities are doing much easier via these online webinars. A lot of the examples I'm going to give today are more of that central Midwest, that Nebraska, Missouri, Kansas kind of region. And Andy and I are both from our Kansas City office, so we have a lot of KC Metro references here to share with you guys today. One of those being that the KC Metro area has had and currently has some regional stormwater standards. So Adam presented some of the DuPage County requirements for BMPs. We also have a BMP manual here in the Metro, where we're looking at more of that 1.37 inch range. When we're talking about some of our other local communities that also need to meet CSO compliance, that water quality storm is very similar to some of the target combined sewer compliance storms that these communities are looking at as well. However, unlike the DuPage County area and the Chicago Metro, you guys have updated your requirements here pretty recently. Some of the regional criteria that we have in the KC Metro area is getting pretty dated here, kind of in the 2011-2012 range. And in those standards, some of the requirements preclude some of those more innovative, sustainable solutions. So we're going to talk through how some of the communities are branching away from the norm and trying to provide a more comprehensive benefit to their area, to their community. So the first approach here is more of a watershed approach, where this community is looking at their jurisdiction on a smaller watershed basis. So this example here is a watershed that's highly developed and is pretty primed for redevelopment here in the next 10 to 20 years. So looking at breaking this watershed down into different topographic regions, an upper region, a middle region, and a lower region, each with varying stormwater management objectives, where they're looking more to use distributed green infrastructure to collect and store stormwater where it falls in the upper zone, trying to identify some more regional detention or retention opportunities in the middle zone. And then as they get to the lower zone there's a natural, well, it's not natural anymore, but a stream or a creek that runs through the center of this watershed and looking to reconnect the system to that stream. So breaking it down by zone, the first is our upper zone here. So this is kind of those first couple of blocks. I mentioned this is an area primed for looking to collect stormwater, pretty much where it falls or in the first few segments of that minor collection system. By using green infrastructure, you not only get a detention-based benefit for those smaller events, you also get some retention. So we're removing some of the stormwater before the system and helping some of those downstream properties from seeing less runoff there. Also in this area is where you start to build out the connections to your middle zone and an opportunity to target some of those known drainage issues. In the middle zone here, this is where stormwater is starting to aggregate. So you're getting 10 to 20 to 30 acres of drainage area. This is a great opportunity to identify some of those more regional facilities. Oftentimes there are opportunities to piggyback on different pocket parks or even larger park spaces where you can have a stormwater benefit and also be used as a public amenity. These can be designed to kind of create those connections from your upper community before you get down into the lower zone. So they act as more control points to help protect those larger event drainage susceptible community members downstream. And lastly, in the lower zone, this is again where we're starting to look at reconnecting to our existing waterways. We need to look at maintaining some more of those overland drainage paths. It's at this point in the system where these properties are more susceptible for, I guess, more widespread or larger flooding issues. Now we're talking about, potentially hundreds of acres of drainage area where, when the system's at capacity for a larger event, the water is going to go here anyway. So how can we get it down to the creek or the stream or that receiving water body without harming our neighbors? So this example here kind of lays all three pieces here together. This is looking at a sub-basin within that watershed example I presented previously. So up in the upper part of the watershed, looking at a more minor stormwater collection system to bring water to some of those smaller green infrastructure facilities, which are then upstream of a regional detention opportunity, capitalizing on an existing park space to enhance a wet detention area. That wet detention facility then acts as a control point before discharging stormwater to the lower system. This sub-basin example has a lot of drainage issues in that lower portion there that's circled in yellow. So this area I mentioned is prime for redevelopment. This area here kind of along that overland drainage path has a lot of parcel vacancies that happen to coincide with the surface stormwater conveyance. So by preserving and reconnecting those overland drainage paths to the receiving stream, this community has an opportunity to create a community amenity, whether it be a trail system but also to protect those new development sites and that redevelopment so that the future developers and community members and property owners don't repeat the same issues that happened 20, 30, 40 years ago, why those people left that area. This slide further emphasizes that importance of preserving those overland drainage paths. So that area circled in yellow on the slide before, this is a zoomed in view of that, along with kind of breaking down this idea of preserving or maintaining overland drainage paths, similar to like a stream buffer policy, I guess you could say, but more from the perspective of protecting those property owners so that we're not allowing people to put their homes, their businesses, their decks in the way of where stormwater is going to go when the system is exceeded, right? There's always going to be some event where we're not able to mitigate that flooding risk. And so to kind of layer on that protection, we need to look at preserving those overland drainage paths for conveyance when that system is exceeded. So here's an example in another, this is a smaller community more in central Kansas. So instead of looking at redevelopment, this is a new development example. These homes were built circa 2014, 2015. The dark blue line on the left side of your screen is a natural channel system. It's an open channel, it's a stream. And you can see this neighborhood here to the right has a stormwater collection system, which then discharges to that stream. From here, we overlay on the contours and derive where the overland drainage paths are going to be. So when that stormwater system is at capacity, it can no longer take any more. This is where stormwater is going to go. It's going to follow those yellow lines. So you can see that when that system capacity is exceeded, these are the homes that are more susceptible. So you've got the overland drainage path that's running through a couple of houses there. These are the homeowners that are more susceptible to those drainage issues. And as you get closer to the stream there, that's a retirement facility, so an even higher risk of people having those drainage issues. So by understanding where stormwater flows, when, not if, that enclosed system capacity is exceeded, that's how we can raise the bar on our stormwater design. We can plan our development accordingly to protect our people and our property. Some other innovative solutions, Andy mentioned this previously, but looking at real-time controls to optimize the stormwater facilities that we're either going to construct or have constructed. The pictures there to the right are a real-time control installation onto an existing detention basin. This detention basin previously had a 1-foot opening at the bottom of the weir wall where the smaller storm events could pass through freely. So again, you're mostly getting that benefit for your larger storm events, and you're neglecting or barely mitigating any effects for those smaller events. This weir structure was retrofitted with an actuated valve and allowing the facility to manage those smaller events more effectively. So this retrofit was targeted to manage those smaller storm events. However, the past few years of data is showing that 88% of storm events are being controlled. And some of those are much larger than the 1.5-ish inch storm event that we would look to controlling for those smaller storm events. So using these real-time controls in lieu of passive control structures can help us more effectively manage our stormwater across a range of events. And yet another community in the metro area is looking at ways to standardize their green infrastructure design without hindering some of that flexibility that is so important to these innovative, sustainable solutions. They'd seen some, I guess, problems or issues or an opportunity to improve in terms of construction and design reproducibility. So standardizing a design approach to not only streamline their review process, but to also get some consistent terminology for contractors that are trying to build this green infrastructure, which again has become more popular in the last 10, 15, 20 years. obviously much newer than the typical pipe and gray infrastructure that a lot of contractors are more accustomed to building. So that standardization of the terminology is very helpful in getting a consistent stormwater management project that functions and meets all of those objectives. So these green infrastructure components, you can see on a small distributed scale here, they act as building blocks, so they can be scaled up from a small stormwater tree planter all the way to a larger wet basin. So this information, this community has detailed it in a green infrastructure manual. This is an example from Kansas City, Missouri, where they've elected to organize those components or those building blocks in different sections. And each of those sections include tools such as checklists and pre-approved planting pallets to help give some guidance to those designers to have kind of unique pieces to the different green infrastructure solutions, but again, to kind of standardize what we're seeing not only on a review side of things, but also that the contractor can learn to easily put these pieces together. So when you go and open each component section, this example here happens to be the soil and aggregate media component. The guidance provides some locations on where these materials are most commonly used, different considerations for the designer, such as assumptions to make. Aaron talked about the importance of assumptions and how some of those assumptions greatly impact your hydrologic components. Well, we also have the same thing on our performance of our green infrastructure facilities. So to get some standardized approaches on materials so that you're not selecting design parameters just to get the results you want, this manual provides some guidance there. And yet another community in the more central Midwest area, this is some examples kind of throughout the Midwest. We've got some up here in the KC metro area as well as Omaha. They're monitoring their green infrastructure so they can have a better understanding of how their systems are performing. So an example, the city of Omaha, Nebraska is using that monitoring data to educate their operations. The city has elected to install valves on their under drains, and based on the results of their monitoring, they're deciding how far open that valve should be open. If the system's performing better than anticipated, that valve might be all the way closed so that you're getting almost full retention at that point from your downstream system. So designing your green infrastructure with those monitoring points is important. If you've got the forethought of installing, let's say, monitoring wells, you can often save time and money on the back end and labor to retroactively try to install a post-construction monitoring well, oftentimes running the risk of damaging your infrastructure, or saving on repeat mobilizations to do some sporadic monitoring. The monitoring also provides important information on maintenance. So when we're talking about gray infrastructure, we need to maintain that system to prevent clogging and blockages so that our system capacity isn't exceeded, whether we're looking at street sweeping or routine inlet cleaning. Well, green infrastructure, that's very important too, especially in the first 1 to 3 years when the facility is becoming more established. So by monitoring this infrastructure, you can get a better understanding of how frequently it needs to be cleaned. So by monitoring our green infrastructure and our stormwater infrastructure in general, we can fix a problem before it becomes a bigger problem that results in a large design change and a repeat project. So a couple of examples here. Kansas City, Missouri has constructed some larger green infrastructure facilities. This first example here, Arletta Park. This was a green infrastructure project constructed to meet combined sewer goals. However, it also has a bunch of additional benefits. So this was an existing park that's been retrofitted with obviously stormwater green infrastructure, which acts as additional landscaping for the park area. And it not only a landscaping upgrade, but it's also spurred street resurfacing and some amenity upgrades within the park. The photo on the slide now is a picture of what that facility, the lowest bioretention facility, looks like about 2.5 years after construction. there with some native vegetations and plantings and some really nice looking stone walls and landscaping. This next example is again a green infrastructure facility with a stormwater management and combined sewer overflow reduction primary objective. However, this facility capitalized on some dead space that was in a residential neighborhood. The area was primarily used for dumping waste. And so this project turned essentially a vacant parcel that, you know, didn't serve much of a community purpose to a more park-like amenity with some walking trails, some landscaping. It actually provides community connectivity between the neighborhood and a bus stop there. Here's a picture again of Rachel Murado a few years after establishment. So by doing projects such as Arletta Park and Rachel Murado, this community was able to leverage the combined sewer initiatives to provide additional community benefits in the form of park space and connectivity trail systems. Coordinating with other infrastructure improvement projects allowed this community to potentially save on excavation and restoration costs instead of mobilizing multiple times to a site. So Andy alluded to this when he was giving us the rundown. Do you remember this example? This was the alleyway that received approximately 4 acres of directly connected impervious area. They saw some localized flooding issues, pretty significant ones, in the alley and said, okay, let's add an inlet. Well, when that inlet didn't fix anything and they further looked and saw that there was a downstream pipe capacity issue, fixing that capacity issue is going to carry about a $500,000 price tag. And then how far downstream do you chase that capacity issue? Are we just pushing it to another bottleneck? So in lieu of that pipe upsize change, a more innovative approach was taken. This was a lower cost solution. So the improvement you're looking at here uses permeable pavement as a continuous collection system. From there, the stormwater, or in this case, the example stormwater from the fire truck, is stored in an underground storage facility. This is a plastic crate system that Andy alluded to, as opposed to a granular subbase. From there, the water is stored before it's conveyed to the downstream system. This community was able to save money and still improve their system without harming the downstream system. Passing it back off to Andy.
Thanks, Maddie. I think we're getting into our time here, so I'll wrap it up. Hopefully you heard some of our bigger messages we wanted to bring today of truly thinking about all the risks when you think about your stormwater designs that you're going to do in the future. Consider a range of storms. I think is important. Historical rainfall events, look at how those systems might work under various conditions. I think is important. We encourage and support the increase in level of evaluation of how you do those designs are important. Continuous simulation models are a big piece of that, and as obviously computers and data become more and more available, I think we should continue to strive to use those. Evaluate all possible solutions. That's one thing we hopefully gave you some ideas of just thinking outside the box. What are different ideas that you could do? Maybe not just doing the typical project you've done in the past, but I guess to challenge everyone to think differently. Maybe there's some different solutions that really do provide a multiple benefit and increase that value to your overall community. I think is important. And then we'll conclude with just some takeaways. Know your system. You have to start somewhere, identify those risks. I think it's important to just do an honest look at your projects and say, what are our total risks, not only at the project site, but downstream? And then define those objectives of what you want and what problems you want to solve, and then what available budget is you have for that, and at least create solutions that addresses the problems, don't create more problems. Stormwater issues, as we all live in this world right now and work in this area, stormwater issues unfortunately are not going away. Aging infrastructure, urban growth, water quality, weather changes, we all have our challenges ahead of us. So I think we need to evaluate new tools and approaches to address those. And finally, I'll just conclude with my bottom line. If you take anything away today, the bottom line is I think there's one more click there, Adam. Maybe not. My bottom line is if you want your stormwater solutions to provide multiple benefit, you need to start designing and implementing it differently. So that's kind of our biggest takeaway, our bottom line. So I think we have a few minutes for questions. So once again, we appreciate the opportunity to present some of our ideas today.
So I'll talk through a question we had here in the chat today from Jamie Locke. Jamie had a question about overflow drainage paths. In urban areas that are already developed, where are those paths proposed? And if they're not on publicly owned property, what strategies should we use or are we using to get property owners to cooperate? Andy, would you like to take that question, or I can jump in too if your voice is tired from 2 slides?
No, it's a great question. I think what our strategy or what we're proposing is trying to think about stormwater design standards into maybe trying to divide those into different buckets. And one of those buckets is, can we look at where the water wants to go and where those overland flow paths are? So obviously we're using GIS tools to identify those, but then the next step is, working with those property owners, which isn't, I know, easy. One positive example we can provide, there was a smaller community south of Kansas City, Grandview, Missouri, where we were looking at some solutions that were going to be pretty costly. And instead, we looked at where the overland flow path was going, and then the city actually worked with a few property owners to come up with, once again, a different solution, which did involve the potential of them having to buy a couple homes, but it actually turned out to be a more of a community benefit scene because those property owners were willing to do not want to live in a flooding situation. So, I mean, those are a lot of what we talked about today, I think, too, is around, communications of communicating with the public what problems you're trying to solve. And so that's kind of my a little bit of a rambling there, but it's one thing I think we need to consider about is if you think about how your community experienced flooding, a lot of it is by the overland flow paths. And I think we, as stormwater managers, need to start thinking about how we can effectively start to reconnect some of those overland flow paths.
All right, we do have one other question real quick. Do you know of any local examples of where Opti technology was used to improve the water quality treatment of stormwater basins?
Well, currently, a couple of the pictures we showed were for water quality benefit in Johnson County, Kansas. The specific community was Lenexa, Kansas. Those facilities are currently in operation. The water quality benefit they're trying to achieve is a higher total suspended solids load reduction. So they're using Opti to see if they can increase that. On those Opti installations, we did pilot a TSS sensor, which we had, I'll just say, significant implementation issues with. We learned a lot about TSS sensors, I should say. So I don't have a positive item to say there, but I think they can be used in the right application, but we didn't have very good luck with that. So that's one specific community where we have worked with Opti on water quality.
All right, well, hey, great job, you guys. That was a great presentation. Thank you very much. Right now, I think that's all we really have time for. We're trying to respect everyone's time here this afternoon. But before we go, again, I'd like to thank all of our speakers one more time. So thank you, Andy, Adam, Aaron, and Madison for sharing your knowledge and experiences with us. I'd like to thank all of you, our audience, for joining us this afternoon. We hope that you enjoyed and learned a few things from the webinar. We will email everyone a link with the recorded webinar, presentations, and a PDH certificate shortly following this program. And please look for our future webinars. We have one in November 12th, I believe, where we will discuss trees and water-sensitive urban design. We'll cover how trees can assist in managing stormwater through the reduction of runoff and the improvement of water quality. So until next time, be safe and be healthy. Thank you very much and have a great day. Go Bears.